And welcome everyone to Beyond the Forecast. I am Chief Meteorologist Michael Stevens, and today I'm going to take you up into, well, just before space. We're talking about the atmosphere today. So we are going to dive in to the 5 main layers of the atmosphere, what they are and what they do. Essentially, what protects us and keeps us safe and allowing us to do what we do on a daily basis. So we'll break that down for you, and then I will talk to you about the cross-section of a hurricane, how they develop, but also the mechanics of it, because speaking of the atmosphere, how big these systems are, the atmosphere plays a role in it. So we'll have that coming up, and then at the end, we'll have a brief segment from our Beyond the Forecast live streaming podcast with meteorologist Haley Fischetti and myself. But before we get too far and into our show, let's talk about some of the fun things here off the top of the show. This day in weather history. I'll see if I can find a picture of this man, but they call him the human lightning conductor. This day, back in 1977, Park Ranger Roy C. Sullivan was struck by lightning for the 7th time. 7th. He was first struck in 1942, again in 1970, 1972, 1973, and 1976. It almost became a yearly thing for Roy to be struck by lightning. That's a wild one. All right, trivia time. Yesterday, we wanted to know how many categories are there to classify hurricanes. Is it 4, 10, 5, or 7? It's 5. Category 1 to Category 5 hurricane. Today, we want to know what layer of the atmosphere is closest to the surface. Is it stratosphere, mesosphere, troposphere, or the crust? QR code. Hit it with your phone and weigh in. And in fact, if you stick around for the first segment, you'll actually get the answer before tomorrow's episode of Beyond the Forecast. So we will have that for you in the next segment or tomorrow for your answer. Weather word of the day. So this is a new segment that we introduced this week, and today we're looking at the word parhelion. Parhelion. So let's break this down. It's actually the scientific term for sundogs. That's right. So when you break it down, para means beside, and helios means the sun. So when you have parhelion, it is beside the sun. It's sundogs. So there you go. That is the word for today. Parhelion. I believe that's how you say it. I'm pretty sure that's how it's pronounced. But parhelion. Take that one to your friends. All right, next up is viewer photo of the day, brought to you as always by Great Rooms. Today's picture comes to us from William, and he sent us this amazing picture up in Sault Ste. Marie from the beautiful shot over the St. Mary's River from Sherman Park. Thank you so much, William, for sending in this absolutely stunning photo, and thank you as always to Great Rooms for sponsoring this segment. All right, get your balloons on so you can float to the atmosphere. I'm going to take you into the layers of the atmosphere, what the 5 main are, and what they do to keep us protected here on Earth, and really why they exist. We'll have that coming up right after the break. And welcome back, everyone, to Beyond the Forecast. I am Chief Meteorologist Michael Stevens, and today we're going to do things a little bit more old school. We're going to have kind of a talking head, but you'll see visuals popping up around me. And today we're going to be talking to you about the atmosphere. One thing we actually really haven't touched on, but meteorology stands for the study of the atmosphere. So let's start at the basics. Atmosphere. Atmos means vapor, steam. So if you go up, there's many different layers to the atmosphere, and it actually keeps us protected here at the surface. There's several different layers that do several different things that keep everything the way we know it. Keeps us breathing, it keeps plants growing, keeps thunderstorms developing, keeps rain falling, keeps the sunshine from baking us to death. But do you know how many layers there are and what those layers do? Well, let's talk about those layers, shall we? So first up, the atmosphere is comprised of nitrogen, 78%, oxygen, 21%, argon, 1%, carbon dioxide, 0.04%, and trace gases. So most organisms, such as ourselves, use the oxygen
to breathe. And then lightning and bacteria perform nitrogen fixation, which produces ammonia, and that is used to make nucleotides and amino acids. So that helps plants grow. Mother Nature's fertilizer. That is what happens with lightning. So let's talk about the structure of the atmosphere. First, at the surface is our Earth, right? And anything that has a pretty significant pull or gravity has an atmosphere. The first layer is the troposphere. So the troposphere is the lowest layer of the atmosphere that extends from the planetary surface to the bottom of the stratosphere. So at first, you have the planet, and then you have the troposphere, and then you have the stratosphere. And now in the stratosphere, that is what extends above the troposphere to the bottom of the mesosphere. So the mesosphere is above the stratosphere. So the first three layers, troposphere, stratosphere, mesosphere. And the stratosphere, believe it or not, is actually the layer in the atmosphere that absorbs most of the ultraviolet light from the sun. That keeps us the safest. So the stratosphere actually helps us, it's our sunblock, if you will. The mesosphere is a layer in where most meteors are incinerated. So you go troposphere, stratosphere, mesosphere, and then we'll get above it in just a second. So if you have meteorites coming in, you know, you can see the amazing sight, or if you've ever seen the videos or pictures of meteorites breaking up in the atmosphere, that's where they're breaking up, is the mesosphere. And some of them, from time to time, do reach the surface as little rocks, but that is where they start catching flame and burning up and breaking up, is a mesosphere. And then above the mesosphere is the thermosphere, which extends from 85 kilometers to the exosphere, which is 690 kilometers up. So the thermosphere is a very big section of the atmosphere, but it is also where the ionosphere is located. That is not a section of our atmosphere, but an ionosphere is where the solar radiation ionizes the atmosphere. So you have the troposphere, stratosphere, mesosphere, and then the thermosphere. And then the next main layer above that is the exosphere. And the exosphere begins at 690 kilometers to 1,000 kilometers from the surface and extends roughly 10,000 kilometers where it interacts with the magnetosphere. So the magnetosphere is kind of the magnetic pole of Earth. So you got the troposphere, the stratosphere, the mesosphere, the thermosphere, and then the exosphere. Those are the 5 main bubbles around Earth that protect us. And then you start see it gradually fading into space. So those 5 layers are kind of like a cake. They're above us, right? And in between each layer of atmosphere is what they call a pause. So when you go up through the troposphere, you have a pause, and then it goes into the stratosphere. So where you have that pause is where you tend to see more of the nitrogen, or you see more of the ionization happening, or you see more of the UV light being absorbed. So as you continue up, each layer has a pause, and then the next layer does something different. So the 5 layers of the atmosphere work together, but also do separate jobs. It's almost like work. So like here at 9 and 10, every person, branch, section does their own job, and it works together to create the product. So the Earth, at the surface, we're just running around doing our daily life, doing our daily things, but in the atmosphere, they're constantly at work, working together and doing separate jobs to keep life as we know it possible at the surface. So that is the 5 layers, the 5 main layers of the atmosphere, even though when you start really nitpicking, it's more like 7 or 8, but again, the ionosphere is not technically a section of the atmosphere, it just ionizes UV light into the atmosphere. But let's go through them again. One more time. You have Earth, where we stand, and has gravity. That allows us to have the atmosphere. So the first section is the troposphere. It goes from the surface up into the atmosphere. You have a pause. The next section is the stratosphere. Stratosphere is what obtains or blocks most of the harmful light from the sun. And then above that you have the mesosphere. The mesosphere is where it actually breaks up a lot of incoming physical objects. And then above that, you have the thermosphere. The thermosphere, above that, you have the exosphere. So those are the 5 layers to the atmosphere that make our world go round and continue to keep us safe here at the surface. It's like 5 shields all layered together to protect the Earth. It's kind of like a suit of armor, if you will. But pretty cool, and they all do separate jobs, all the way down to the troposphere at the surface. So a little fun fact for you about science, but also about weather, because meteorology is the study of that atmosphere. Why we can breathe, why weather does what it does, why it interacts and creates things that we see down here at the surface. Super fun. We'll have more on Beyond the Forecast right after the break.
And welcome back, everyone, to Beyond the Forecast. I am Chief Meteorologist Michael Stevens, and we told you about Hurricane Eric last week, where it rapidly intensified from a tropical storm to a Category 4 hurricane in less than 24 hours. And we are now right in the middle, or I should say at the beginning, of hurricane season, and that will go all summer. But we've shown you how a hurricane develops. We've shown you what happens when a hurricane storm or a storm surge and a hurricane move on shore. But let's kind of show you the cross section of a hurricane, how it develops and becomes that massive storm. So first up, it's all about the circulation. So what happens is you get that heat, the very warm waters, usually whether it's the Atlantic Ocean or the Gulf or the Pacific Ocean, those warmer waters rise. And the faster that warm air rises is how much you get when it comes to circulation. So essentially what happens is you have that warmer water rise, makes a bunch of little thunderstorms, and then they start coming together, and then the flow starts spreading outward at a certain height. So it gets upwards in the atmosphere like we talked to you about today. Once it gets to a certain point, it starts curving. It starts spreading out, and that's where we start getting the size. But it also starts setting up 2 things for us. It starts setting up high pressure above the storm and low pressure at the surface. So where you have high pressure, that is cleaner air, drier air, and that sinks down to almost a low pressure system. But that's creating the eye of the hurricane. And then low pressure here is starting the circulation. That's why you see it going counterclockwise. But in the eye, everything's pretty still, pretty quiet, as high pressure does. So you have that high pressure above the center, really at the top of the storm, and that sinking air results in those clearer skies and setting up that low pressure. Now let's talk about that circulation, that rising motion. So we start getting those storms as that warmer air rises, creates those thunderstorms, right? And then we start seeing those thunderstorms come together. High pressure forms the eye, while it's the center, low pressure, which spins counterclockwise, starts getting that motion. So as that warm air rises, those thunderstorms start to develop, and then we start getting that counterclockwise circular motion, low pressure. So you have high pressure at the top giving you the eye of the hurricane, low pressure at the bottom giving you that counterclockwise motion, and the thunderstorms are the reason all of that is created. So that low pressure system is because of that warmer air creating those thunderstorms, which in result is creating that low pressure. So there you go, high pressure above the storm, creating that clockwise motion, while down at the surface where you have that low pressure, you have that counterclockwise motion. It is just a massive system. So you have high pressure, low pressure, you have storms continuing to develop, pushing that air out and creating that motion. And when you have it rapidly intensifying, it gets even crazier. So if you think about Tropical Storm Eric turned into Hurricane Eric within 24 hours, and it wouldn't be a big deal if it went from a tropical storm to a Category 1, but it went to Tropical Storm Category 1, Category 2, Category 3, Category 4 in less than 24 hours. That is how warm those waters are at the shore. It's so warm that it picked up so much and it continued to build so quickly that it went from 75 miles per hour to 140 miles per hour winds within that storm. So that is the difference between warm water and very warm water. That is rapid intensification. So the result of everything that we just told you is that sinking air near the center means clearer skies for the eye. That low pressure system continues to develop and wrap. And this is kind of what the cross section of a hurricane looks like. You can see you have the eye right there, and then you can see where the thunderstorms develop, and that outward motion is where high pressure kind of is sitting.
right? So it goes up, spreads out, continues to develop this big system, and then low pressure starts that pinwheel motion. And that's what a hurricane looks like kind of from the bird's eye view. There's the eye where you have very quiet, very still conditions. And in fact, if you ever look at the eye of a hurricane, sometimes you'll see birds in the eye, and they just hang out there until the storm becomes pretty much nothing. But the wall of the eye, that is where you most likely will have the strongest winds, because that is where everything, think about centripetal force, right? When you have something spinning, the strongest force is going to be where the center is. So the hurricane eye, that is quiet. That's where high pressure is. The wall, that is where you have the strongest of the winds, as well as quite a bit of rain and also some pretty significant thunderstorms. And that's kind of what it looks like with the clouds above it. You can see feeding that eye as that air is sinking. So you can always see that motion into the eye, low pressure at the bottom, counterclockwise, and then you just have this massive system. Its one sole purpose is to grab moisture and then move whichever direction it wants to go. But then when it makes landfall, you have those extremely gusty winds, you have extremely heavy rain, you have the very high chance of tornadoes, and then not to mention, once it dissipates, then you have to pick everything up and continue to watch the skies for the rest of the summer. So that's kind of what a hurricane looks like after it forms when you cross-section it. So there you go. Pretty wild to think that Mother Nature can create something this big and this destructive. And it's all started with warm water and thunderstorms. We'll have more from Beyond the Forecast coming up right after the break.
And welcome back, everyone, to Beyond the Forecast. Now, every week, every Tuesday, 10 a.m., me and meteorologist Haley Fischetti, we sit down and we have our Beyond the Forecast live streaming podcast, where you can sit down and discuss with us a certain topic. Sometimes it's a random topic. Other times we put one on the Beyond the Forecast Facebook page and have you vote on which topic you want to talk about for that week. This week we talked about summer and the heat and a few other things because we started talking to you, and sometimes we get sidetracked. But here's a segment from it.
Do you prefer this heat or cold? And a lot of people, it was kind of split 50-50.
Yeah.
A lot of people were saying we prefer the heat and humidity, and others were saying that, oh, we prefer that over 30 degrees or 9 degrees.
Right.
And I'm against that.
Yeah.
And the reason being is scientifically, you should prefer the cold because it is much easier to warm up. You can throw on layers. You could.
Because your body's always trying to stay warm.
It takes less energy to warm up.
Yes.
It takes much more energy to cool down.
Yeah,
And it's
it
the
does.
laws of thermodynamics. So when you look at a cold room and a warm room, warm molecules are all spaced out.
Yep.
Cold molecules are condensed
Condensed.
and falling.
Yes.
Cold, denser air. So if you're going to warm that up, all you have to do is space them out and warm air takes over. If you're trying to collect all the molecules and bring them together to condense them and make it colder, it takes far more energy.
It does, yeah.
Hence why you see rolling blackouts when you have heat waves like this, because everyone's flipping on their cold air makers. You don't have this issue when everyone's flipping on their warm air makers.
Exactly. Yeah. It's easier to warm.
It is much easier to warm than it is to cool.
Yes.
Because cooling is, you got like two processes going on. One, you have to make heat in order to cool down.
Yes.
Whereas if you're making heat, you're just making heat. So
You can-
a little bit different.
It's always like when it's cold out and everyone's like, oh, just like run a lap outside and you'll get warm. There's no like, besides like dip in the water.
Yes.
That's the solution for when it's super hot out.
That my wife spent 7 hours in the pool, I think, on
Good
Sunday
for her.
because it was, very hot. I didn't realize how hot it was Sunday.
Yeah, it was
I
hot.
stayed inside in my Dracula
Dungeon?
cave.
So you can catch that every Tuesday on the Beyond the Forecast Facebook page, the 910 News YouTube channel, and the 910 News Facebook page. So join us every Tuesday, 10 a.m. to discuss some science and weather. But thank you for joining us today on Beyond the Forecast. I do appreciate it. And tomorrow we'll be back at this time, 4:30, to bring you Friday's episode of Beyond the Forecast, which involves Viewer Question Friday. So for meteorologist John Gross, as well as meteorologist Haley Fischetti, thank you so much for being here. We do truly appreciate it. Be good, stay safe, take care. We'll catch you guys all tomorrow.